Morning, students. Can you hear my voice now?
Yes, sir, you are audible.
Okay, thank you. Good morning to everyone. Okay. So today I am going to solve some more problems in elimination of arbitrary function. Okay. First problem is eliminate the arbitrary function. F from z equal to x square plus 2 into function of 1 by y plus log x. So let us take this is equation number 1. Differentiate equation 1 partially with respect to x and partially with respect to y. First, differentiate equation 1 partially with respect to x. So we'll get a dou z by dou x. Dou z by dou x is p. If you differentiate x square, we'll get 2x plus 2 into. If you differentiate this function, we'll get f dash of 1 by y plus log x. If you differentiate the function, the argument, that is 1 by y plus log x with respect to x, you will get here 0 because you are differentiating with respect to x. So log x, if you differentiate, you will get 1 by x. This is equation 2. Similarly, differentiate equation 1 partially with respect to y. We will get dou z by dou y. Dou z by dou y is q. Q equal to, this is 0 plus twice f dash of 1 by y plus log y. If you differentiate 1 by y plus log y with respect to y, you will get, if you differentiate 1 by y, you will get minus 1 by y square. This is 0 plus 0. So this is equation number 3. From 2 and 3, we need to eliminate f dash. So from 2, what is p minus just 2x. From this 2x goes this side. So p minus 2x is equal to 2 by x. P minus 2x is equal to 2 divided by x into f dash of 1 by y plus log x. Okay. From this, what is the f dash of 1 by y plus log x? F dash of 1 by y plus log x is equal to x into t minus 2x divided by 2. Similarly, from equation 3, f dash of 1 by y plus log x. Calculate f dash of 1 by y plus log x is equal to minus y square q minus y square q divided by this 2. From these two, because the left hand side is same, so and hence right hand side is same. So from these two we have, so 2 gets cancelled. X into t minus 2x is equal to minus y square q, or px minus 2x square equal to minus q y square. So usually you should write the final answer in the form of p into something plus or minus q into something, and is equal to a function of x, y, z. So p, q, and then the right hand side you can write the remaining thing. So remaining you have here 2x square. This is the final answer. So at least you should write the final answer, because next question I am going to ask, I'm not going to solve the problem. Just I'm going to ask the final answer. Okay, you should try to tell. Okay, I will write the second problem here. I'm not going to solve the problem. Form the PDE from the function z equal to y square plus 2 into function of 1 by x plus log y. Log y. So what is the final answer? So here you have x square, here you have y square. Wherever you have x, here you have y. So that is the only difference. But can you predict from this answer to this answer without solving? But later you can solve. Just you can try. Maybe sometimes it is correct, sometimes it is false. Don't hesitate to try. Okay. Otherwise, I will give the answer. So the final answer is px square plus qy equal to 2y square. You can check it later. So eliminate the arbitrary function from or form PDE. Should write form the PDE from xyz equal to function of x plus y plus z, where phi is the arbitrary function. Now, so let's take this is equation 1. Differentiate 1 partially with respect to x. So if you differentiate 1 partially with respect to x, here you have left hand side x and z. Both of them are function of x. So you need to differentiate. You should treat y as a constant. So UV method. If you differentiate with respect to x, you will get yz plus keep x. If you differentiate z, you get dou z by dou x. Dou z by dou x is p equal to phi dash of x plus y plus z. If you differentiate x plus y plus z with respect to x, 1 plus 0 plus dou z by dou x is p. Now, similarly differentiate equation 1 partially with respect to y. We will get again y and z are y is a function. You know that y is a function. Y here, z is also a function of y. So UV method, keep x to differentiate y with respect to y1. So x into z plus x into keep y. If you differentiate z with respect to y, you get dou z by dou y, that is q equal to phi dash of x plus y plus z. Again, if you differentiate x plus y plus z, you'll get 0 plus 1 plus q. This is 3. So now we need to eliminate phi dash. So 2 divided by 3. Equation 2 divided by 3. Left hand side is what? Yz plus xy p divided by xz plus xyq. So phi dash of xyz plus divided by phi dash of x plus yz cancel. So remaining we have 1 plus p divided by 1 plus q. Cross multiply and simplify, and they should write finally in terms of what? P into something plus q into something is equal to a function of xyz. So that is the final answer. So I will write for this problem. So yz plus xyp into 1 plus q is equal to xz plus xyq into 1 plus p multiply yz plus yzq plus xyp plus xypq multiply xz into 1 xz plus xzp plus xyq plus xypq. xypq gets cancelled. So as I told already, you should take p terms separately. So p into xy minus xz, then q terms separately, plus q into yz minus xz, sorry, xy, equal to some function of xyz. Here you have xz minus yz. So this is a required PD. Eliminate the arbitrary functions. F and G from z equal to x into f of y by x plus y into g of x. I think the last class we solved a similar type of problem. Can anyone tell the statement? Just the function. Okay, I will tell.
f of z minus xy, comma x square plus a square.
I think I'm not hearing properly. Maybe you are correct, but I don't know exactly. But I want to tell the problem. I will tell you. Please check it whether I solve this problem or not.
Okay.
Z equal to x power n into function of y by x.
Yeah, sir. We solved.
Yes, sir.
It's okay. It's okay. At least you replied something. It may be wrong. I don't expect a correct answer usually. So I need the response from your side, because otherwise I am speaking lonely here. So if you interact something, then the class is little bit interesting. So the whole 1 hour, it is very difficult to speak from my side. It is very difficult to write in the board. So try to understand my difficulty also. At least you should respond something. Okay. So Z equal to x power n into f of y by x. So this is a problem I solved in the previous class. So but here you have extra, you have y plus y into g of x. Okay. So you take, this is equation number 1. So again here you have two functions. So here in this problem we have only one function. So the final answer is the first order PD. But here you have two functions, f and g. The last class also I solved problems with the two functions. The final answer is second order. If it is two functions, then you should find P, Q, R, S, T. Everything you need to find out, whether you are going to use or not. Okay. Sometimes you will use everything. Sometimes you will use out of 5 will 3. Sometimes you will use out of 5 you will use 4. Okay, it's depending upon the problems and depending upon your thinking ability. So it's okay. So it is better to find everything. Okay. Now, okay, this is equation 1. Differentiate 1 partially with respect to x. So dou z by dou x is p is equal to, again, this is a function of x, this is also a function of x, uv rule, x into f dash of y by x. If you differentiate y by x, you'll get minus y by x square plus function, keep f of y by x as it is. If you differentiate x, you'll get 1, so into 1 plus y, because you are differentiating with respect to x, y is constant, so g dash of x. So you call this is equation, okay, you simplify further and then you call equation 2. This is p equal to, here you have x, here you have x square, you have minus, so minus y by x into f dash of y by x plus f of y by x plus y into g dash of x. We call this is equation number 2. Okay. Now differentiate equation 2 partially with respect to y. So if you differentiate y, sorry, equation 1, not 2. Differentiate equation 1 partially with respect to y. So dou z by dou y, dou z by dou y equal to q. Okay. So here have x, this is function of y. So x into f dash of y by x dash of y by x. If you differentiate y by x with respect to y, you will get 1 by x plus y into g of x. So if you differentiate with respect to y, 1 into g of x or just g of x. If you simplify this, you'll get q equal to x gets cancelled. So f dash of y by x plus g of x. So this is equation 3. Now I am going to differentiate 2 with respect to x. Actually 2 is dou z by dou x, dou z by dou x. Differentiate equation number 2 partially with respect to x. So if you differentiate partially with respect to x, you get a dou square z by dou x square. That is r. Okay, so I'll take minus y commonly. Remaining you have 1 by x into f dash of y by x. So you are differentiating with respect to x. So again UV rule. So keep 1 by x as it is. If you differentiate f dash of y by x with respect to x, you will get f double dash of y by x. Again, if you differentiate again y by x, you will get minus y by x square. Plus, and then you should keep f dash of y by x as it is. Then here have 1 by x, because minus y is commonly taken out. So remaining have 1 by x. So if you differentiate 1 by x with respect to x, you will get minus 1 by x square. So close the bracket. So now I just to differentiate 1 by x into f dash of y by x. So UV rule. Next I am going to differentiate f of y by x. So plus f dash of y by x. Again, if you differentiate y by x, you will get minus y by x square plus here y into g dash of x. So y is constant. Now, if you differentiate g dash of x, you will get g double dash of x. So I call this is equation number 4. Okay. Now, P, Q, R. Okay. Now you can differentiate equation 2 with respect to y, you will get S, or you can differentiate equation 3. Equation 3 is what? Okay. This is dou z by dou y. Yeah. Okay. Dou z by dou y. Okay. If you differentiate equation 3 partially with respect to y, you will get dou square z by dou y square. Okay, I will write again equation 3 in the next slide, and then I will differentiate. So q equal to f dash of y by x plus g of y, g of x. Equation 3 I am going to rewrite. Q equal to f dash of y by x plus 3 g of x. So this is equation 3. So now differentiate equation 3 partially with respect to y. Okay. So actually this is what? Dou z by dou y. Dou z by dou y. Okay, if you differentiate equation 3 partially with respect to y, you will get what? Dou square z by dou y square. So that is equal to PQRST. This is T equal to differentiate this with respect to y, you will get f double dash of y by x. If you differentiate y by x with respect to y, you will get 1 by x plus this is function of x. You are differentiating with respect to y means 0. So you call this is equation number 5, because already 4 I used in the previous slide. So 5. Now one more thing, PQRT. One more thing, yes. Now differentiate equation 3 partially with respect to x. Partially with respect to x. So that means dou square z by dou y dou x. The mixed partial derivatives are equal because we are considering only the continuous functions. So that's why you can write this is dou square z by dou x dou y also. This is yes. This is yes. If you differentiate equation 3 partially with respect to x, we'll get f double dash of y by x okay. If you differentiate y by x with respect to x, you'll get minus y by x square plus differentiate g of x with respect to x means g dash of x. This is equation number 6. Okay. Now I am going to use equation 5 in 6 here. So s is equal to f double dash of y by x into 1 by x. I just write the right hand side of 5. Okay, into what is the remaining we have here? F double dash of y by x into 1 by x is here. Remaining is minus y by x. If I multiply these two, you will get this plus d dash of x. So this is nothing but t. So s is equal to t into minus y by x plus d dash of x. I call this is equation number 7. Now, equation 2. What is equation 2? Equation 2 is p equal to minus y by x plus f dash of y by x. Okay, this. I am going to multiply this p by x. So px. Similarly, I am going to multiply this q by y. So px plus qy. Suppose if you calculated px, you can tell. Otherwise, I will write. So px from equation 2 and 3. So from equation 2 and 3, we have px plus qy. So please check it. Px minus y into f dash of y by x plus x into f of y by x plus xy into g dash of x. This is px plus qy, y into f dash of y by x plus y into g of x. Okay, now I think these two terms are gets cancelled. Minus y into f dash of y by x plus y into f dash of y by x gets cancelled. Remaining we have, I will write the remaining term here. Okay, the next slide I will write. So the remaining term is what? xy into g dash of x plus x into f of y by x plus y into g of x. Only these three terms. This is equal to left hand side. Left hand side is px plus qy is equal to xy into g dash of x, xy g dash of x plus x into f of y by x plus y into g of x. So what is this? Anyone tell what is x into f of y by x plus y into g of x? So hint is, if you see the statement of the question, you can tell the answer.
Z.
Yeah, is it? Okay. Now, xy. So I want to eliminate the g dash of x also. So g dash of x, I think on the previous slide, equation 7, please check it. G dash of x is equal to what? S plus ty by x. This is g dash of x. So instead of g dash of x, I would write s plus ty divided by x plus z. So this is by 7. So here it is by equation 1. That is a given problem. So now multiply xy is xy x s plus s gets cancelled, y square t plus z. So the left hand side is px plus qy. So this is the vacuum PD. Okay. So next problem, eliminate the arbitrary functions. Class எடுத்துருக்கோமா சொல்லு என்ன 312 312 வந்துட்டு you should go, that's should go straight and then left. ஓகேவா? It's a physics lab கிராஸ் பண்ணி போகும். 312. Okay. So eliminate the arbitrary function. Functions, because two functions here, arbitrary functions f and g from is that equal to function of ax plus by plus g into cx plus dy. Cx plus dy. Okay. So let's take this is equation 1. So again, you should differentiate one partially with respect to x, y first. So anyone tell if you differentiate equation 1 partially with respect to x, please tell.
P equal to
Very good. P equal to
f dash of ax plus by
dash of ax plus by. Okay.
into a
Okay, I'll
A.
write into a. Okay.
plus g dash of cx plus dy into c.
Okay. C. Okay. Okay. Thank you. This is equation 2. Similarly differentiate equation 1 partially with respect to y. Okay, differentiate equation 1 partially with respect to y. So yeah, anyone?
D into
Sorry,
f dash of d
QR.
into
Ah.
f dash of ax plus by
Okay.
plus d into g dash c
Look,
plus dy.
into B வருமா? B வரும். Here B.
B, yes, sir.
Plus
D into
okay, D into
G dash of
CX plus
cx
D.
plus dy.
Okay. Okay, good. Thank you. And this is 3. Similarly, differentiate equation 2 partially with respect to x again. And differentiate equation 2 partially with respect to y. Okay, I will write, I can't write again equation 2 here. But if you write in your notebook, differentiate equation 2 partially with respect to x and tell the answer. I will write in the next page. So I will write first differentiate equation 2 partially with respect to x. So anyone?
R equal to
R equal to
a square into f double dash of ax plus by
a square into f
F
double
double
dash.
ax plus by
Okay.
plus c square into
Ah.
g double dash of cx plus dy.
I think G double dash
Yes, sir.
G double dash of CX plus dy. Okay, thank you. Good. Okay, this is equation 4.
Yes, sir.
I think
4, sir.
yeah,
4,
4,
sir.
4. Okay. Okay. So R equal to a square into f double dash of ax plus by plus c square into g double dash of cx plus dy. Okay. Now differentiate equation 2 partially with respect to y. Okay. So anyone?
T equal to
What with y? You are differentiating 2 with respect to y. That means the left hand side of 2 is what? Left hand side of 2 is p. P is nothing but what? Dou z by dou x. If you differentiate this with respect to y, you will get dou square z by dou x dou y. That is s. Okay. You start s. S is equal to
f double dash of ax plus by into ab
okay, f double dash of ax plus by
plus by to
okay
ab
into ab. Okay, please write, please write. நான் ஒரு பக்கம் எழுதுறேன், அது ஒரு பக்கம் போயிட்டு இருக்கு. Okay, so I'll write a little bit neatly. Okay, ab into f double dash of ax plus by
plus
okay
g double dash of cx plus dy into cd.
Okay, cx plus dy into cd. Okay, yes, good. Thank you. Okay, this is equation number 5. Okay, I think we got p, q, r, s, t. I need t. Now differentiate 3 because 3 is what? Left hand side is q. Okay, q is nothing but what? Dou z by dou y. Dou z by dou y. I need a t. So if you differentiate this with respect to y, I will get a t. So okay, differentiate equation 3. Differentiate equation 3 partially with respect to y. So I think somebody is ready to yeah.
T is equal to
T
B
equal,
square F double dash.
okay, V square F double dash.
B square F double dash.
Ah,
AX plus BY
okay,
plus D square
okay,
G double dash CX plus DY.
okay, good, thank you. Okay, okay, this is equation 6. So now we need to eliminate F double dash and G double dash from equation 4, 5, 6. Eliminating F double dash and G double dash from 4 and 5, 6 we get. So I think the last class we have 2 equations and 2 unknown. For example, AX plus by equal to 0 or some constant C, okay, and or 0, okay, Cx plus dy equal to 0. Then if you need the non-trivial solution, okay, we find what determinant of AB, CD is equal to 0. If you expand the determinant, we'll get the final answer. But here we have 3 equations. Okay, equation 4, 5, 6. So for this, to eliminate F double dash and G double dash from 4, 5, 6, I am going to use the concept of matrix. So determinant of first row or A square C square. Second row S A B C D. Third row T B square D square. So determinant equal to 0. So I'll write here R. The first row is R A square C square S A B C D, and third row T B square D square. Okay, so I don't expand this determinant about this row. It is better to expand about this column because I need the final answer in terms of R into something plus S into something plus T into something. So R into, leave this column, leave this row, AB D square minus B square CD minus S into, I am expanding about this column. S into, leave this column and leave this row, A square D square minus B square C square. And then plus T into, leave this column and leave this row, A square CD A square CD minus ABC square is equal to 0. Okay, I think here what is common? BD is common here. So R into, if I take commonly BD, remaining you have what? Remaining you have AD minus BC minus S into, so x square, A square minus B square. So A plus B into A minus B. So AD minus BC into AD plus BC. Plus T into here I think A and C is common. Remaining we have AD minus BC equal to 0. So I think throughout the AD minus BC is common. You can divide AD minus BC. Finally, you'll get R into BD minus S into here. Yeah. Refresher course. BTech. சரி 450 to 550 இந்த ரூம் சொல்லுவாங்களா சரி R okay RBD plus sorry minus S into AD plus BC plus T into AC. So this is a final answer. This is a required PD. If you want to write, you can write what is R, what is S, what is T. Okay, that is you know that. That's why I leave it. Okay. Now time is 9:38. So I try to finish one more problem, last problem. Okay. If U equal to f of x square plus y plus some function of x square minus y. Show that dou square u by dou x square minus 1 by x into dou u by dou x minus 4x square into dou square u by dou y square equal to 0. So solution. So let us take u equal to already u is here, so it is better to take v equal to x square plus y and w equal to x square minus y. Okay, so now I write the given problem is u equal to function of v plus f of v plus phi of w. This is equation number 1. Okay, now differentiate equation 1 partially with respect to x. So dou u by dou x. Differentiate 1 partially with respect to x. I will write the first one. You will try to tell the remaining one. Dou u by dou x is equal to f dash of v, and if you differentiate v with respect to x, you will get 2x plus phi dash of w. If you differentiate w with respect to x, you will get 2x. You call this is equation 2. Now differentiate equation 1 partially with respect to y. So can anyone tell the answer? Dou u by dou y equal to
F dash of V minus phi dash of W.
f dash of v minus, okay, thank you, pi dash of w. Okay, this is equation 3. Okay, now differentiate equation 2 partially with respect to x. I will write here. Okay, I don't write here. Okay, I will write in the next slide, but you write equation 2. Okay, equation 2 is this. Okay, I'll go to the next slide. Differentiate equation 2 partially with respect to x. So that means dou square u by dou x square, because already you have dou u by dou x. You are differentiating with respect to x. So dou square u by dou x square. If anybody got the answer, you can tell. Okay, otherwise, what is dou u by dou x? I will write here. Dou u by dou x is equal to f dash of v into 2x plus pi dash of w into 2x. So I'm going to differentiate this one with respect to x. Okay, and also we should know what is v and yeah, please tell.
4x plus double dash of v.
Sorry, again repeat, please.
4x into double f double dash v.
4x x square.
4x square.
Okay, 4x square
F double dash v
f double dash of v
plus 4x square phi double dash of w.
4x square pi double
Phi
dash of the
double.
no term irukku. You told 2 terms, still you need to tell 2 more term. Correct, paadi correct.
Plus 2 into f dash of v
Okay,
plus 2 into phi dash of w.
okay, thank you for both of you. So please check it. Here it is written directly. Otherwise, I need to explain here. Okay, dou square u by dou x square equal to okay. If you keep f dash of v, if you differentiate 2x, you'll get it 2. So 2 into f dash of v is here, and plus you should keep 2x as it is. And if you differentiate f dash of v, you'll get f double dash of v. And if you differentiate v is what? X square plus y. So you'll get 2x. So 2x into 2x, 4x square f double dash of v. Similarly, you should do for pi dash of w and 2x. So I think I leave that part to you. So if you do that part, you'll get these 2 terms: 4x square phi double dash of w and 2 into phi dash of w. Okay, I call this is equation number, I think 3 or 4.
Four, sir.
4. Okay. 4. Now differentiate. I think okay. Differentiate equation 2 partially with respect to y. I think this is equation number 2. Equation number 2 is same. Dou u by dou x is equal to f dash of v into 2x plus pi dash of w into 2x. I need to differentiate this one with respect to y. So dou u by dou x dou y. Sorry, dou square u by dou x dou square u by dou x dou y. If anybody got the answer, you can tell. Dou square u by dou x.
Sir?
Yeah.
I have a doubt, sir.
Yeah, please tell.
We don't have to differentiate equation 2 with respect to y, no, sir, because we have there is no term asked in the question as dou square u by dou x y dou y. Dou y dou y.
There is no need. You are telling there is no need to find equation 2 partially with respect to y.
Y. Yes, sir.
Yes, you are right. I'll check the statement. Okay. Yes, you are right. So there is no need. Okay, I leave this part. Suppose if we need, we can find later. Okay, thank you for your observation. I think now time is over. I think so. I think you have the second hour, huh?
Yes, sir.
Okay, I don't want to take that hour. So it is better to continue this question, try to finish it. Otherwise, tomorrow 6th hour, I will finish it and then I'll go to the next section. So I finished the elimination of arbitrary constant and I finished elimination of arbitrary functions. Okay, thank you. If you have any more doubts, you can ask to me. Otherwise, you can ask the next class. Okay, thank you.